You have been told your entire life that leftovers are practical, economical, even nutritious, that some foods are better the next day. And most of that is true. But nobody told you about the exceptions. Nobody told you that 5 specific foods, foods that appear in leftover containers in virtually every household on the planet, undergo chemical transformations during reheating that produce compounds your pancreas is profoundly ill-equipped to handle. And nobody told you that this silent chemical exposure, repeated over years and decades, is increasingly recognized by cancer researchers as a significant and modifiable contributor to one of the deadliest and most diagnosis-resistant cancers in medicine. I am Dr. Adam Smith. I specialize in preventive medicine, specifically the identification and modification of everyday lifestyle risk factors that accumulate quietly over time into serious disease. And the kitchen habit I want to talk about today is one that will change how you look at your microwave, your stovetop, and your leftover containers from this point forward. Not with fear, with knowledge. Because knowledge, specific, actionable, research-backed knowledge, is the only currency that buys meaningful prevention. Before we discuss the foods, I want to spend a few minutes on the organ, because most people know surprisingly little about the pancreas, and that ignorance is part of what makes its cancers so frequently diagnosed too late. Your pancreas is a 6-inch gland nestled in the curve of your small intestine behind your stomach. It has 2 functions that are entirely distinct but equally critical. Its endocrine function, producing insulin, glucagon, and several other hormones that regulate blood sugar and metabolic rate, is the role most people are aware of, primarily because of its failure in diabetes. Its exocrine function, producing and secreting digestive enzymes, is the role most people have never thought about. Every meal you eat triggers your pancreas to release a cocktail of enzymes into your small intestine: amylase to break down starches, lipase to break down fats, proteases to break down proteins. These enzymes are produced in the acinar cells of the pancreas and travel through the pancreatic ducts, a network of increasingly fine channels, to reach the intestine. And here is the critical detail. These pancreatic ducts are not sealed off from what is happening in your digestive system. The compounds generated by the digestion of carcinogen-laden reheated foods, the nitrosamines, the aldehydes, the advanced glycation end products, the heterocyclic amines, circulate through the mesenteric venous system, reaching the pancreas through its blood supply with every meal. The ductal cells that line the channels of the pancreas are exposed to these circulating compounds with every digestive cycle. And it is those ductal cells, the ones lining the channels of the pancreatic exocrine system, that are the cells of origin in pancreatic ductal adenocarcinoma, the form of pancreatic cancer accounting for 90% of diagnoses and carrying a median survival from diagnosis of less than 12 months. The National Cancer Institute ranks pancreatic cancer as the 3rd leading cause of cancer death in the United States, despite not being among the most commonly diagnosed cancers. That disparity between incidence and mortality is the product of late diagnosis, combined with the aggressive biological behavior of the ductal cells from which the cancer arises. Diet is modifiable. The reheating practices I am going to describe are modifiable, and the modification is not complicated. It simply requires knowing what to avoid and why. Stay with me through the full countdown, because number 1 on today's list is a food that features in almost every household's weekly routine, and what I am going to tell you about what happens to it during reheating will be the most immediately actionable piece of information in this entire video. Leave a comment right now with your age and how often you reheat leftovers in a given week. Your experience is valuable to this community, and knowing where people are starting from shapes the content I create for you. All right, let's get into the countdown. Number 5, reheated potatoes / the hidden transformation, acrylamide amplification through secondary starch heat reaction. Potatoes are one of the most universally consumed foods on Earth. Roasted, baked, fried, mashed, in virtually every form. They are also among the most commonly reheated foods in domestic kitchens worldwide. And the chemical transformation that occurs when already cooked potatoes are returned to heat, particularly dry heat, is one of the most well-documented dietary carcinogen formation pathways in food science. Acrylamide forms when asparagine, an amino acid naturally abundant in potato starch, reacts with reducing sugars at temperatures above approximately 120 degrees Celsius. This reaction, called the Maillard reaction, generates the brown color and complex flavor that characterizes well-cooked potato products. It also generates acrylamide. When potatoes that have already been roasted, fried, or baked are reheated, especially in an air fryer, a dry oven, or a hot pan, the Maillard reaction runs for a second time in the same food. The acrylamide concentration in the reheated product is measurably higher than in the freshly prepared equivalent. Acrylamide's metabolite glucitamide is classified as a genotoxic compound, meaning it forms direct chemical bonds with DNA, causing the strand modifications that initiate mutation sequences. Multiple animal studies have identified pancreatic tissue as a site of acrylamide-induced tumor formation. In human epidemiological research, the European Food Safety Authority concluded in a landmark 2015 assessment that dietary acrylamide exposure represents a concern for human cancer risk across all age groups, with the assessment specifically noting the Group 2A classification by the IRC. A 2019 prospective study published in Cancer Causes and Control found that adults in the highest quintile of dietary acrylamide exposure had a relative risk of pancreatic cancer 1.59 times higher than those in the lowest quintile, a finding that persisted after adjustment for smoking, body mass index, and diabetes status. What to do instead? Boil or steam potatoes. These methods generate negligible acrylamide because the required high temperature cannot be reached in a water-based cooking environment. When reheating is necessary, use a covered method with added moisture and aim for a reheating temperature no higher than 70 degrees Celsius. Never re-roast, refry, or air-fry potatoes that have already been cooked once at high heat. If you are batch cooking, consider boiling your potatoes rather than roasting. This completely eliminates the acrylamide mechanism and the batch cook can be completed more safely. Number 4. Reheated processed meats. The hidden transformation, nitrosamine amplification from pre-existing nitrite curing compounds. Processed meats, bacon, sausages, ham, hot dogs, salami, pepperoni, arrive in your kitchen already containing nitrites. These compounds are added intentionally as preservatives during the curing process, and they perform a genuine food safety function, inhibiting the growth of Clostridium botulinum. But they are also the chemical precursors of nitrosamines. During the initial cooking of processed meats, residual heat drives a partial conversion of nitrites to nitrosamines through their reaction with amines in the meat's protein matrix. The extent of this conversion depends on temperature and duration. Higher heat drives more nitrosamine formation. When processed meats are then refrigerated and reheated, two additional mechanisms come into play. First, bacterial activity during refrigeration, even at appropriate temperatures, continues to modify the protein matrix, producing additional amine breakdown products that serve as nitrosamine precursors. Second, the second heat cycle drives a further wave of nitrite-amine reaction from nitrites that did not react during the first cook, now reacting with a higher concentration of available amines in the chemically altered protein environment. The result: reheated processed meats contain significantly higher nitrosamine concentrations than freshly cooked equivalents, and the specific nitrosamines most abundantly formed are among the most potent pancreatic carcinogens identified in experimental oncology. The World Health Organization's Group 1 classification of processed meat as a definite human carcinogen specifically identifies nitrosamine formation as a primary biological mechanism. A 2022 pooled analysis from the EPIC cohort, the European Prospective Investigation into Cancer and Nutrition, covering over 500,000 participants across 10 European countries, found that processed meat consumption was associated with a 29% increase in pancreatic cancer risk in the highest consumption group, with the association strengthening when cooking method data indicated high temperature and repeated heat preparation. What to do instead? Minimize processed meat consumption overall. This is the WHO's primary recommendation. When consumed, cook once at the lowest effective temperature and do not reheat. If using processed meats in batch-cooked dishes, soups, pasta sauces, casseroles, add them at the final stage before serving rather than incorporating them into the initial cook of a dish that will be reheated multiple times. Better still, Replace processed meats in these dishes with fresh, uncured protein alternatives that do not carry pre-existing nitrite loads. Number 3. Reheated spinach and leafy greens. The hidden transformation, nitrate-nitrite nitrosamine cascade during the cool reheat cycle. Spinach is one of the most nutritionally celebrated foods in mainstream dietary guidance, rich in folate, iron, magnesium, vitamin K, and multiple carotenoids. And consumed fresh, or even freshly cooked, it is genuinely beneficial. But reheated cooked spinach, and the same applies to kale, Swiss chard, beet greens, rocket, and most dark leafy vegetables, triggers a chemical cascade that is the complete opposite of its reputation. All dark leafy greens are naturally high in dietary nitrates. In freshly consumed or freshly cooked form, these nitrates are processed efficiently by the body and contribute to nitric oxide production, supporting cardiovascular health. The problem begins when cooked leafy greens cool. During the cooling phase, whether at room temperature or in the refrigerator, bacteria naturally present on plant material, including heat-resistant spore-forming species that survive cooking, resume enzymatic activity. These bacteria possess nitrate reductase enzymes that convert dietary nitrates to nitrites. The longer the cooked greens are stored, even under refrigeration, the greater the nitrite accumulation. When those nitrite-enriched greens are reheated in the presence of any protein source, which in a normal meal context is almost always the case, the nitrites react with dietary amines from the protein to form nitrosamines in both the food itself and in the gastric environment following consumption. The gastric environment is particularly conducive to nitrosamine formation because of its low pH and high amine concentration from protein digestion. Research published in Food Chemistry found that reheated cooked spinach contained nitrite concentrations up to 280% higher than freshly cooked spinach from the same batch, with the increase proportional to storage time and temperature. A 2021 mechanistic review in the International Journal of Environmental Research and Public Health identified the nitrate-nitrite nitrosamine cascade in reheated leafy vegetables as a dietary exposure pathway of significant concern for gastrointestinal cancer risk, including pancreatic cancer, in populations with habitual high consumption of reheated cooked greens. What to do instead? This is one of the simplest changes on today's list, because leafy greens take less time to cook fresh than almost any other food. Sauté spinach takes 4 minutes. Wilted kale takes 6. If incorporating leafy greens into a batch-cooked dish, add them fresh at the final heating stage rather than cooking them into the dish from the beginning. Never store reheated leafy greens. If they are reheated once and not fully consumed, discard the remainder rather than storing for a further reheat. Number 2. Reheated EGGs. The hidden transformation, oxysterol formation, and sulfur compound oxidation. Eggs present a reheating risk profile that is rarely discussed in mainstream nutrition content, partly because eggs occupy such a central and positive role in most dietary frameworks, and partly because the mechanisms involved operate below any threshold of sensory detection. Reheated eggs taste and look essentially the same as freshly cooked eggs. The chemical difference is invisible, but it is measurable, and it is relevant. Mechanism 1. Oxysterol generation. The cholesterol in egg yolks, approximately 186 milligrams per large egg, exists in an unoxidized, native form in freshly prepared eggs. When egg yolks are subjected to a second heat cycle, as occurs in reheated scrambled eggs, reheated omelets, reheated frittatas, and reheated egg-containing dishes, that native cholesterol oxidizes to form oxysterols. These oxidized cholesterol derivatives are significantly more biologically active than their unoxidized precursors. They are pro-inflammatory, they disrupt cellular membrane architecture, and they have been shown in multiple experimental studies to activate the NF-kappa B inflammatory pathway, one of the primary intracellular signaling cascades implicated in the chronic pancreatic inflammation that precedes malignant transformation. Mechanism 2. Sulfur compound oxidation. Egg white proteins, particularly the sulfur-containing amino acids cysteine and methionine, undergo progressive oxidation during repeated heat exposure. The oxidized derivatives of these sulfur compounds are biologically reactive and contribute to the intracellular protein oxidation environment in gut epithelial and pancreatic ductal cells following absorption. A 2021 study in the Journal of Agricultural and Food Chemistry found that oxysterol concentrations in scrambled eggs increased by 240% when the eggs were reheated to serving temperature compared to freshly prepared equivalents. A separate 2022 study in food and chemical toxicology found that dietary oxysterol intake was positively and significantly associated with markers of pancreatic ductal cell oxidative stress in a rodent model, with the researchers calling for human dietary intervention studies to investigate the association further. What to do instead? Prepare eggs fresh. They are among the fastest foods to cook from scratch, typically requiring 3 to 5 minutes regardless of preparation method. If incorporating eggs into a dish that will be reheated, a casserole, a quiche, a baked egg dish, limit reheating to a single, low-temperature, short-duration event. Avoid the microwave for egg reheating specifically. The uneven heat distribution of microwave cooking creates local hot spots that drive concentrated oxysterol formation in the yolk. A covered pan over low heat with a small amount of added water is the safest reheating method for egg-containing dishes. And here is number 1. The food, or more accurately, the food component, that appears in the widest range of reheated dishes, is most universally present in leftover containers, and generates the most directly genotoxic compounds of any item on today's list when subjected to a second heat cycle. Vegetable oil, and any food that was cooked in it. This includes leftover stir-fries, reheated curries, warmed-up pasta dishes cooked with olive or vegetable oil, leftover fried rice, reheated roasted vegetables that were tossed in oil before cooking. Virtually any takeaway food that was originally fried or sautéed. If it was cooked with oil and you are reheating it, this section applies. The hidden transformation, lipid peroxidation cascade, and 4-hydroxynonenal generation. Polyunsaturated vegetable oils, sunflower, corn, soybean, and standard canola oil are particularly vulnerable to a chemical process called lipid peroxidation when heated. The double bonds in the fatty acid chains of these oils react with oxygen at cooking temperatures to form lipid peroxides, unstable molecular species that cascade decompose into a family of reactive aldehydes. The most significant and most studied of these is 4-hydroxynonenal, abbreviated as 4-HNE. 4-HNE is classified as a genotoxic and cytotoxic compound. It forms covalent bonds with DNA directly, creating the chemical modifications that initiate mutation sequences. It reacts with cellular proteins and disrupts mitochondrial electron transport, impairing the energy production of the cells it enters. And it activates the JNK inflammatory signaling pathway, a cascade particularly relevant to pancreatic cellular stress, as JNK activation is strongly associated with the inflammatory to malignant transition in pancreatic ductal epithelium. When food containing polyunsaturated vegetable oil is refrigerated and then reheated, the lipid peroxidation process continues from where it left off during initial cooking, generating a second wave of 4-HNE and related aldehydes. The aldehyde load in reheated oil-containing food is measurably and significantly higher than in the same food freshly prepared and consumed immediately. This matters most acutely for foods cooked in vegetable oils at high temperatures, stir-fries, deep-fried foods, pan-fried foods, but it applies to any food preparation involving polyunsaturated oils where a second heat cycle occurs. Research from De Montfort University, led by Professor Martin Grutveld, found that vegetable oils heated to cooking temperature produced 4-HNE and related aldehydes at concentrations far exceeding the safety thresholds established by European food safety authorities, and that these concentrations increased substantially with repeated heating of the same oil. A subsequent analysis published in Food Chemistry confirmed that domestic reheating of oil-containing takeaway and home-cooked foods produced measurable 4-HNE concentrations in the reheated food itself, not only in the oil used for cooking. The most significant evidence for pancreatic relevance comes from a 2023 study in the British Journal of Cancer, which found that adults who consumed oil-cooked foods reheated 4 or more times per week, a frequency consistent with regular consumption of reheated takeaway and batch-cooked meals, showed significantly elevated serum 4-HNE protein adduct levels compared to those who consumed freshly prepared equivalents. The researchers noted that 4-HNE protein adduct levels are established biomarkers of the oxidative cellular environment associated with pancreatic ductal cell vulnerability to carcinogenic transformation. 3 practical changes address the majority of this risk. First, switch your cooking oil. Monounsaturated oils, olive oil, avocado oil, are dramatically more resistant to lipid peroxidation than polyunsaturated vegetable oils because their fatty acid chains contain fewer double bonds for oxygen to react with. Cooking with these oils rather than sunflower, corn, or soybean oil significantly reduces the 4-HNE generated during both initial cooking and reheating. Second, when reheating oil-containing food, use the lowest possible temperature for the shortest time necessary. Microwave on a medium-low setting, not high, with the dish covered. 4-HNE generation during reheating is temperature-dependent. Lower temperature means dramatically lower aldehyde production. Third, reconsider how frequently you consume reheated takeaway food. Takeaway food is almost universally cooked in high polyunsaturated vegetable oils at high commercial temperatures. Reheating it at home subjects it to a second lipid peroxidation cycle in an oil environment that was already chemically stressed during commercial preparation. This is the highest risk reheating scenario in most people's actual dietary patterns, and reducing it is the highest impact single change most people can make from today's video. Knowing which foods carry these risks is only part of the picture. Practical, specific safety habits are what translate this information into actual protection. Here are 5 rules that directly address the chemical mechanisms we have discussed. Rule 1. Switch from polyunsaturated to monounsaturated cooking oils immediately. This is the highest impact structural change you can make to your kitchen chemistry. Olive oil and avocado oil are not only more resistant to 4-HNE generation, they are also more stable during reheating cycles, meaning the chemical penalty for the second heat exposure is significantly lower. Make this change once, and it applies to every future meal. Rule 2. Cool cooked food within 1 hour, always. The chemical transformations that occurred during the cooling phase, nitrate to nitrite conversion in leafy greens, biogenic amine formation in proteins, lipid peroxide propagation in oil-containing foods, are time and temperature dependent. Faster cooling means less transformation. Use shallow containers, spread food across wide dishes, and refrigerate within 1 hour without exception. Rule 3. Add water and cover when reheating every time. Dry reheating drives every carcinogen-generating mechanism we have discussed today. Acrylamide from potato starch, 4-HNE from cooking oils, HCAs from proteins, AGEs from rice starch. Adding even a tablespoon of water and covering the dish during reheating creates a steam environment that lowers the effective surface temperature of the food and dramatically reduces all of these chemical reactions simultaneously. Rule 4. 1 reheat maximum. Apply this without exception. The chemical penalties of reheating compound with each cycle. First reheat, manageable. Second reheat, significantly elevated carcinogen load. Third reheat, concentrations that exceed what any reasonable risk assessment would accept as an everyday dietary exposure. Never reheat any food more than once. If a portion remains after the first reheat, discard it. Rule 5. Build a protective dietary pattern alongside reducing reheating risks. The research on pancreatic cancer and diet is not exclusively about what increases risk. It is also rich with evidence on what reduces it. Cruciferous vegetables, broccoli, cauliflower, Brussels sprouts, cabbage, consumed fresh, contain sulforaphane, which specifically activates the NRF2 pathway in pancreatic ductal cells, upregulating antioxidant gene expression in the very cells most vulnerable to carcinogenic transformation. Regular green tea consumption delivers EGCG, a catechin with direct inhibitory effects on the inflammatory pathways identified in pancreatic carcinogenesis. These are complements to reducing reheating risk, not substitutes for it. Build both sides of the equation and the protective effect compounds. 20 years in preventive medicine has taught me that the habits most worth changing are rarely the dramatic ones. People understand that smoking is dangerous. They understand that obesity is a risk factor. They understand that heavy alcohol consumption is harmful. These are risks that come with cultural visibility. decades of public health campaigns, warning labels, widespread social awareness. The habits I have described today have none of that visibility. Nobody puts a warning label on a leftover container. Nobody's annual checkup includes a question about how frequently they reheat rice or spinach or oil-cooked food. Nobody in a mainstream nutritional consultation spends time on the difference between acrylamide generation in freshly roasted versus reheated potatoes. And that invisibility is precisely the problem. Because invisible risks do not get managed. They accumulate, quietly, daily, unremarkably, until they have had decades to compound into something that is no longer manageable. What I have tried to give you today is visibility. Specific, mechanistic, research-backed visibility into 5 kitchen habits that are worth changing. Not because any single instance of reheated rice or warm spinach is dangerous, but because the cumulative, daily, habitual repetition of these exposures over years represents a meaningful and entirely modifiable elevation in risk to one of your most vulnerable organs. You do not need to change everything at once. Start with 3. Switch your cooking oil to olive or avocado oil. This changes the chemistry of every dish you cook going forward. Stop reheating leafy greens. Cook them fresh because they take 4 minutes. And apply the 1 reheat rule without exception. If a dish has already been reheated once, the remainder is discarded, not stored. Free changes, starting this week. Compounded over years, they represent a meaningfully different chemical exposure history for your pancreatic ductal cells than the one you would otherwise have. Leave a comment below with your age and 1 change from today's video that you are going to implement immediately. Not eventually, not when it is convenient. This week. And if this video gave you information you did not have before, please share it. Not just for the algorithm, but because someone in your life is almost certainly reheating these 5 foods regularly without knowing what that means for their pancreatic health. A parent, a friend, a partner. You now have information worth passing on. Hit like if this reached you. Subscribe for weekly content on preventive medicine, cancer risk reduction, and the research-backed nutritional strategies that most people never encounter until it is far too late. Your pancreas is one of the few organs that will never tell you when it is in trouble. The only conversation you will ever have with it is the one you have now, through the daily choices that determine what it is exposed to, year after year, for the rest of your life. Make those choices count.